action. Hi, this video is about planning your high-powered mobile off-grid, that's redundant, electrical system. And hopefully it's going to get a lot more interesting than that. Hi, I'm Matt from Mango Vans. We're going to talk a little bit about the big picture of electric power, AC versus DC, batteries. This is not a deep dive. We're just splashing around in the shallow end here. Let's jump in. Let's slowly wade in. AC versus DC power, alternating current or direct current. Alternating current is going to be you're more familiar with in your house. If it goes into an outlet like this, it's got 3 wires for grounding it. It's alternating current. If it's DC powered, something like this marine water pump, a red and a black, it's going to get wired to something like a fuse block, 2 wires, and it runs directly off of a battery. Something with alternating current is going to go through an inverter if the power source is a battery. And if you're coming off of 12 volt or 48 volt DC power, a little foreshadowing there, you would go directly off a battery. So are these 2 batteries the same? They're different voltages. So we're back to DC now. Let's go quickly between a lower voltage 12 volt DC and a higher voltage 48 volt DC. We're going to do a little math. Don't worry, there's no numbers, just letters. This is our standard formula. Watts is power, voltage, and then amps is your current. Let's do some quick math. Don't worry. I'm going to do it very fast just to show you an example. So this is a 48 volt battery, and its storage capacity is 100 amp hours. This is a 12 volts battery. It's got 270 amp hours of storage. So does that mean that this is twice as good because it has 270 or 100? No, obviously not, because look at our formula. So let's do some math. 12 volts times 270, 3,200 watts. Watts is what we care about. That's power. And now we know amp hours and we know voltage, but to get a real meaningful number to ask ourselves, how many powerful devices and loads can I run for a significantly long period of time off these batteries? We want the watt hours. So we've got 3,200 here, then we do our 48 times 100 volt. We do our 48 volt times 100 amp hours, and you get 4,800 watt hours. And what that really boils down to is 3.2 kilowatt hours and 4.8 kilowatt hours. This guy has 48% more storage capacity. Okay, keep going. What does that really mean in the real world? Well, let's run a simple test here. We're going to run something like a 3,000 watt load off of a Victron multiplus inverter charger. Now this guy is going to be taking that 30,000 watt load through its 48 volt system, and it's going to be pulling out 65 amps. Run 3,000 watts off of your 12 volt, you've got 250 amps. So when we're wiring a 12 volt system, we need to pass the amps, the current, through 4-aught gauge wire, which is very thick, cumbersome, but even more important for efficiency terms, as we're going through long distances with this huge cable all through that copper, we're getting a voltage drop, and we're also generating heat, which is always going to happen through physics. And as energy goes through and electricity is dissipated into heat, we're losing our efficiencies. So we can wire a 48 volt system with something as thin and elegant as 2 gauge, because there's a lot less, like we talked about, 65 amps versus 250 amps needing to travel through from our power source to the load that's taking the power. Okay, there we go. Why does this matter to us? So we know that we want to get alternating current as much as we can because we don't want to be running through an inverter and converting things up and down and losing a lot of power. We don't want to be running huge cables. And so now we're looking at what are modern electronics taking. A lot of our modern world wants to be DC native. What's in your phone, your laptop, these are batteries that just want to be charged directly from a battery. So when you're charging your block of your laptop charger into the wall, what actually you're doing is you're taking this power, going through that block, it's converting it down to DC, which is what the battery inside your laptop wants. It's also what a lot more things in our modern world want, like electric vehicles and huge data centers that are running off of server rack batteries. So all these semiconductor chips that are training AI, they're going directly off of this. So we can go directly from solar, which shoots out DC power, to a battery, which stores that DC power to our loads that are now taking DC power. What is the most high power draw important DC load that we would have here in South Florida is an air conditioner. So we can use a 12-volt air conditioner, which are good, but a 48-volt air conditioner is still staying DC, so it's more efficiency, but it's a high wattage, so we can really run more power. And I'll just keep rambling, because a DC-based air conditioner can use a variable speed compressor, not just a hard clunking on-off. You can feather in as the load, as the temperature in your climate is requiring more or less power. It's not just off on, off on. You're going to get a much more longer run time and much more power. What are some other final loads in your van that would want a DC load? Well, your Starlink, they're going to come out of the box with something, again, that you're going to plug into an AC outlet and run through an inverter to pull that power from your battery. You don't need to. Get a very simple converter kit, because this is DC native. And you can just pull your power, boom, boom, right to your fuse block, right off your battery. So I think that's enough for today. Hopefully that was somewhat interesting and you learned something. The main takeaway here is we're not putting on, the future is not going to be old school RVs with generators, these big, heavy, loud, obnoxious, kind of like your ex. We don't need these clunky pieces of machinery anymore, and we don't really need an inverter for too much. We still do. We're not kicking out inverters. We need alternating current power for electric water heaters, induction cooktops, and some other loads like that. But really, if we're thinking wisely to build an elegant, efficient system for really, really high power, if you're just wanting to do some basic stuff, you want some pumps and lights and fans, and you still are okay with just plugging into an inverter to power your laptop, no problem. But what we're building here, these are mobile power stations. We're building multiple big air conditioning systems that need to run for hours and hours and hours with Starlink, with communications coming through. So between climate and communications, we are going in this direction. And now luckily, the lithium battery market has expanded so much that we can now hit these loads. Whereas maybe in the past you would, once something gets to be so many watts, you need to go through an inverter, you need to be on a generator, you can only do it on shore power. We can now load up such a robust 48-volt lithium system that we are in a whole new dimension. So that was a lot of numbers and maybe some vocabulary. And if I got anything totally wrong, tell me. And if anything was unclear, I'll try harder to explain it better. Ask me some questions about it. I hope you enjoyed all these props. A little carrot head thing going here. Carrot top. And that's it for today. Thank you. Thanks a lot. Cut.